Delta 1398 is declaring an emergency. We've got plenty of fuel, and onboard souls are by. Souls on board 92. Probably up returning to Boston. We have a fume event, kind of like smoke in the cabin.
1398, right. You said the Boston Airport, the current vector is turn left heading of a 130, 130 heading. You're descending maintain probable 240.
Left turn heading 130-240 descent, Delta 1390. We'll be right back.
The electrical power system uses automatic control to protect the system from source failure or load failure. Our main topic today is a DC system. The Boeing 737 primarily uses an AC electrical system, but it also has a DC system to support various functions. The DC power is supplied by transformer rectifier units and of course the aircraft's battery. The TRUs play a key role in the DC system, of course. They convert 150 volt AC power from the main generator into 28 volt DC power. The 737 is typically equipped with the 3 TRU, labeled TRU1, TRU2, TRU3, and of course the battery charger for the main battery. Each TRU is connected to different DC buses to distribute power efficiently. The aircraft battery provides backup DC power when needed. It operates at 24 volt and is essential during engine start and APU start and as emergency power source if the normal power is lost. The battery is charged by the battery charger TRU when the aircraft is powered. So, so after we get 150 volt from the IDG, it's supplied to the AC transfer bus, and from the AC transfer bus, it goes all the way down to the TRU. The TRUs convert 150 volt into a DC volt, 28 volt. So we have a TRU1, TRU2, and the TRU3, which mainly supply the battery bus in order to supply the battery and charge it in case we used the batteries, the main battery, for example, to run the APU. The battery will be drained after the APU will complete its rotation. So we use the TRU3 to supply the battery bus, and the battery bus is supplied to the battery to make the battery once more in charge condition. In case of an AC power failure, the battery automatically powers the standby electrical system, ensuring critical instruments remain operational. The standby power system includes the battery and standby inverter. The standby inverter and essential DC and AC buses. So in Boeing philosophy, they have categorized buses such as a standby bus. The standby term is used when the main DC or main AC is failure. So the standby is will continue to power up the aircraft in case of emergency, of course. So the term standby used to indicate that this bus is so the term standby is indicate that this bus will operate in case of emergency condition. So we have ground bus, the ground bus, ground service bus. The ground service bus, from its name, this bus will uh, 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 this bus will uh, operate only on ground. And we have galley bus. The galley bus is, from its name, of course, it's equipped with the galley tools such as oven and heaters, etc. In case of emergency condition, the galley bus will be shed, which means that this galley will be shed or not used in case of emergency. Some aircraft will be equipped with one battery. Some will be equipped with two battery, main battery and auxiliary battery. We have a mastermind for the standby power, which is a standby power control unit, or SBCU. The unit is located on the B6. This unit is to control the distribution of DC power. As we said, the standby power, with the loss of normal power, the standby power system supplies a minimum of 30 minutes of AC and DC power to systems necessary to maintain safe flight. The battery supplies DC power. The static inverter uses battery power to make AC power. The SPCU, or Standby Power Control Unit, controls the distribution of AC and DC standby power. And of course, to control this system, I mean AC system and DC system and standby power system, we have three modules: electrical meters, battery and galley power modules, and generator drive and standby power modules, and AC systems, generator and AB modules. And in order to protect the AC and DC and standby power, we use switches and circuit breaker. Circuit breaker, of course, allow power to the buses, and in case a breaker will be to close, that's mean to let power through it. And we have, of course, fuses. The difference between circuit breaker and fuses: the fuses is a one-time used, and circuit breaker is multi-time use. To continue the protection system, the breakers close when the command of the GCU to close it. The GCU is generator control unit. The GCU closes the breaker only when the power is good. The power is good mean that the power is on the limit that the GCU is monitored. If the power coming to the aircraft from the ground power unit or the GPU is under or over this limit, the GCU will not command the circuit breaker to close. So these are the main breakers in the electrical system: the EBC, or external power contactor, or the ABU power breaker, ABB, and generator control breaker, or GCB. This is a complete schematic for the electrical system. As we can see, this is generator 1 and 2, and this is ABU. We have generator bus, or AC bus 1 and AC bus 2, and we have, of course, AC transfer bus 1 and 2. We have AC main bus 1 and 2. So this schematic is add something a little bit not familiar for some. They create a generator bus. So normally the schematic for the electrical system for the Boeing 737, they don't have generator buses. They starting from AC transfer. Okay, to sum up, the DC system in the Boeing 737 play a crucial role in keeping essential aircraft system running. TRUs convert AC to DC power. The battery, of course, provides a backup support in case of main electrical sources fail, such as IDG1, IDG2, and ABU. And of course, electrical buses ensure efficient power distribution. So in the next video, we will demonstrate more in practical way how to interface with the three panels in the 737 NG. Thank you for watching. If you have found this video helpful, don't forget to like and subscribe and hit the notification bell for more aviation insight. See you in the next video.